Hello. As the basis of simulating systems, we should have a definition from system, and that means any phenomenon that can take a bunch of data as an output and after performing a process generate data as output, which here, as you can see in this figure, we have inputs, and then there's process, and also we have some disturbances that will affect on our system, and finally we have our outputs. As you see, most of the systems based on this static, maybe either static or dynamic. Also, there are different categories in system that I try to explain some of them here. In the first category, there are two sets. We have dynamic and static systems, which their current output is dependent to the output of previous system. Systems are dynamic, and the systems which their current output is not dependent to the previous system, is a function of performance of current system, is static. And in the second category, we have discrete and continuous systems. Discrete systems are systems that their outputs discrete in the series of time, and continuous means that is determined continuously by time. It is the concept that we have in Simulink, in the concept of discrete and continuous systems, as we have in the next concepts. There are two different simulations in Simulink. First one is discrete simulation that we use them for discrete system, and then the second one is continuous systems or continuous simulations that we use them for continuous systems. For example, here we have an example here from continuous and discrete system that we have given from the Simulink. As we can see in the above figure, we have a continuous system, and the below figure we have a discrete system that, as you can see, it is working in a specific series of time. And now there are other categories too. We have linear and non-linear, that the Simulink can do both linear and non-linear simulations. As you know, the linear systems is one of the difficult systems to simulation, but based on the Simulink software we can do it easily. Also, we have chromatic and specific systems. We have open loop and closed loop that is common in control engineering. Then finally we have time dependent and independent of time systems.